Hello, so I'm Marcos. I work for ThoughtWorks. I'm based in the Porto Alegre office in Brazil. I'm sorry that I have to give this presentation in English, but my Spanish skills are lacking, to say the least. So concurrency. Enough music? Concurrency, right? A quick definition. So concurrency is doing multiple things simultaneously. So you have a big task, like you have multiple big tasks, and during this task, there is some time that you can actually do something else because that task is blocked for some reason. So concurrency is actually switching between those two tasks, so they can be done quicker than to wait for one to finish and do the other, while parallelism is to do both at the same time. So how do you guys deal with concurrency in your apps? Who here actually has some, in the current application, has some threaded code or some concurrency code? Anyone? Oh, okay. A few people. So if you ask this to many Ruby developers, you get an answer similar to that. Hey, my app is concurrent. I use Death Server. Oh, I use Unicorn. I use Fin, Puma, or whatever. So for most Rubies, concurrency stops at choosing an application server, right? We can get into fights about which one is faster. You have many benchmarks, but that's all. You rarely see people talking about threads or actually using threads in their codes. It's mainly choosing. You choose your application server, and you're fine. So that mindset can lead you to slow or unscalable apps. And I have a true story to tell. That's what inspired this talk in the first place. So we're building an application to do some data migrations for a client, a big client. And it was we need to migrate from a Mongo database to another one. But during that process, we need to fetch data from many different APIs. So we went to build that project. We did it. The code was very good, very clean. Everything's tested. It worked just fine. But the problem is, it was slow as hell. It took like a day for the whole migration to finish. Those APIs were very slow. Some of them couldn't take many requests, but the code was very good, but still slow. And one day, a new developer joined the team. He was coming from a very strong Java background, and he took a look at hey, nice, you have tests, but why you don't do, there are no threads in here. Why you don't use some kind of thread pool for that? And then the whole team was looking at each other and collective facepalm. Because it was a perfect application for concurrency. Everything was I/O bound. We are only waiting for the network to. But since it was a pure Ruby application, we couldn't use Unicorn, so nobody actually think about using threads in the first place. Whatever. I can just spend more dynos. But this is also a part of the Ruby mindset. That everybody is making lots of money, we have lots of users on our applications, and we live in the cloud. So who cares about performance? Just put another computer there. That's the cloud, right? Well, sorry. So why do we we still treating concurrency as a secondary concern, if it is a concern at all? Why do we do that? Because concurrency reminds us of threads. And no sane person likes threads, right? Who here gets up in the morning, oh, I'm going to do some threaded code, I love that. Nobody, right? Because it reminds us of all those things, racing condition, deadlocks, process starvations, all those horrible things that we see in college and never encounter again in real life because we are Ruby developers and we have application servers. So those things are horrible. If you have all those terror stories about bugs that only happen in the winter solstice during the midnight and nobody can debug them, it's horrible, right? So look at this code. It doesn't do anything, but it's threaded. So you have all those mutexes and conditional variables, and it doesn't do a single thing. You still have 10 lines of nothing just because it's threaded. So threads are evil, right? Everybody agrees. But barely spinning a thread doesn't leave you in deadlock hell, right? You don't say thread new, boom, deadlock. That's not what happens. When things start to break down and you start to having winter solstice bugs, when you have mutable shared state. So mutable shared state is the root of all evil, right? So how do we deal with concurrency issues? If the problem is mutability, shared mutability, then we deal with concurrency issues by controlling that mutability. And even, there are many techniques and models that just for how you control the mutability in your system. You have software transaction memories, you have atomic operations, you have per functions. If you see like Haskell, that they think that mutability is so evil that they call it unclean. It's impure. You have Go channels, and also you have actors. So the actor model is, instead of thinking about threads, you think about concurrent objects or entities, to not confuse with object orientation. Our communication between those entities is done with async, immutable, and immutable is very important, messages. And you don't have any shared state between the actors. It's just messaging going in, messages going out, immutable. Everything is nice and clean and pure if you talk to Haskell guys. So each actor can have its own state, and it can do whatever it wants with its own state, as long as it doesn't share that state with any other actor. It only talks through messages, and these messages are asynchronous, so you don't wait for an answer. You just send a message, and you might get called back. That's the actor model. Each actor has its own mailbox, so it receives those messages starts to pile up in the mailbox, and when the actor wants, it can process them in the order it wants, and you can call other actors when it's done. It's a perfect concurrency model. So from the point of view of one actor, it's a single-threaded continuous program, but you can have many actors concurrently. It's funny because actors and object orientation, they go back a long way. So actors, the first paper that talks about it, it's from 73, and the first version, public version, I don't know, of Smalltalk is from 72. So this is one of the famous Alan Kay phrases about object orientation, that it means only messaging, local retention, and protection, and hiding of state processing. And this is a definition of actors. See the difference? You know, one of those guys is slightly smarter than the other one, but besides that, they're kind of similar. So actors and object orientation, they have a common foundation. I read in a wiki, so it might not be true, but the reason they call those things messages is because of Smalltalk and the whole messaging thing. And I read somewhere else that the reason that Smalltalk have messages is because of actors. So they influenced each other a lot. So it's actually hipster object orientation, right? It's so old before anyone was talking about that. But besides that shared history, the actors are much more popular in functional languages like Erlang, that has a lot of actor stuff, and Scala that has the Akka framework that's very famous. And what about Ruby? So Ruby has a somewhat shaky relationship with concurrency, I was telling before. So if you go to the internet, you can see all those codes like, hey, Ruby doesn't scale. Oh, we have the interpreter lock. Ruby is impossible to be parallel. Node.js is so much faster. Please delete all Ruby code you have and start writing Node.js apps. You have all those blogs comparing, hey, my Node.js blog is much faster than your Ruby blog. Well, not really, right? So concurrency is a complicated topic, and all those things are complicated, but there's been a lot of recent good things, especially on alternative implementations like JRuby and Rubinius. They are much more concurrency focused. And people are starting to talk more about like concurrency, so it's a good thing. And also, there are many different actors implementations for Ruby, because you can really write an actor implementation with 20 lines of code, although I'm not going to do that live. But you can do it. It's a very simple. But of course, if you want to really work with that, you need something a little more robust. So you have celluloid that I'll talk more about. You have Actors RB, which comes with Rubinius. And they're now, it's released as a gem. You have this Go Friday thing. That's a very interesting name. So, and I'm going to talk a little more about celluloid. So celluloid, the idea is to grab the concurrency aspects of actors and try to leave it as much object-oriented and Ruby as possible. So this is a celluloid actor. But it's just like a normal class, right? You just have a module there and boom, actor. So what the hell is the mailbox? So the secret of celluloid is the use of proxies and futures. When you have like that actor class that I have, and you do new, it doesn't bring you an instance of that class. It brings you a proxy, a celluloid actor proxy. That for most methods, it doesn't do anything. If you just call a method, the proxy just stay there, quiet, and pass the method along. It takes the time. It's gonna block. The method blocks, if you're gonna block your thread, it's just a normal method call. The proxy stands there but doesn't do anything. So, this is not very interesting, but when things start to get cool is when you use async. So you call async on your proxy object, and then you call whatever method you want, and that method will be fired immediately as a message to the actor, and you get new back instantaneously, because that thing is going to be doing in another thread concurrently. So you make a method call to the proxy passes the method call to the actor and gives you new. You don't get the results. But that actor can call another actors, and that's how things go. And also, celluloid also has the concept of futures. So you can call this future method and then a method upon it. And you instantaneously get a future object. That's like a promise, using the JavaScript thing, that sometime in the future, this guy will have the value of your method, but not right now. So you can call the future method, do some stuff. The method is running on the background, and when you try to access the value of the method, then the whole thing stops, and you grab the result back. But you can do whatever you want between those two calls. So that's how a call with future works. You call the proxy calls the actor, but returns you the future, and the future keeps talking to the actor until it has the value back, and you can access it. Everything is underlined by Ruby fibers and threads, but it's well hidden, so we don't have to have deadlocks nightmares. But what if an actor fails? So you cannot just throw exceptions with a code like that, because every actor is running in its own thread. So if you just throw up exceptions in the air, the whole thing, it's not going to work. So the celluloid actor took the failure model that Erlang, the Erlang languages uses, and tried to implement it in Ruby. And the Erlang failure model is pretty much turn it off and on again. So Erlang is built with this whole concept of like fail is okay, just restart everything, just because then everything will be fine. And celluloid has the same features. You have linking supervisors and supervisors groups. I'll talk a little more about supervisors, but all those features are very cool. So here it's a worker, a normal actor, and in that method it's making a HTTP call. And we all know that HTTP calls can go wrong. So that thing can throw an exception. So celluloid has this method, supervise as, or you pass a name that you want this actor to be called in the future, and the Google thing is arguments for the constructor. And it returns you what it calls a supervisor, what the guy does. And also it starts the actor. So you get two objects when you do that. To access the actor, the actual actor, you need to use what it's called the Actor Registry. And the actor will be registered in the registry with the name, the symbol you pass. When you call work and something bad happens and that guy crashes, the supervisor is going to take care of restarting that actor. So the actor is always running. And you don't worry if it crashes. If it's something like HTTP calls where crashes are normal and you don't need to worry about that, the actor can just boot up again and you try to do the same thing again. That's an implementation of the Erlang model. So this actor thing is funny and cool, but what difference it makes? So we have this, it's being talked as a poster child for actor success in Ruby. It's the Sidekick Library. Anyone here ever heard about it? So we have some hands. So Sidekick is basically a rescue implementation, like a job queue. So but the main difference is based on celluloid, so it uses actors as while rescue doesn't. And people are finding that when using this thing, you can cut down costs a lot because it can handle much more jobs than rescue, even though it doesn't do anything different. It doesn't add any features. Well, now it does, but it started as just a copy, but based on actors. So you can save a lot of money if you start to worry about concurrency, and you can make a big difference in the end. I don't know about you, but money, it's not infinite. It's not like the cloud. It runs out eventually, so it makes a difference. So, concluding, concurrency is hard. You cannot just have a Rails initializer that includes celluloid in every class and boom, super scalable application. You need to think about those stuff. But ignoring it will make it go away. Like doing what the Ruby community has been doing, like saying la la la, I have my Joe, you cannot touch me, deadlocks, it won't work, it's not sustainable. But there are many available models and solutions for concurrency that are not dreadful. But Ruby is lagging a little, but you can go into other communities and just see what they're doing and bring back to our fold. So Ruby doesn't lose its importance in the future. So please, look out of the box, think a little about those concurrency issues, see what Erlang is doing, what Scala is doing, what Clojure is doing, or Haskell, and bring it back to the Ruby fold. That's it. Thanks.